So in the last exhibition chemistry, we took a deep dive into a microscale version of the traditional cracking experiment. If you haven't seen that, make sure you go back and watch that before you watch this video, because everything we're doing today builds on that. If you have, then stick around. We're going to be making one of these little catalyst tubes, which is going to open up a massive range of opportunities for you to demonstrate some really cool chemistry. Let's have a look. So about a year ago, I promised that we would be returning to Bruce Mattson's fantastic microscale gas chemistry techniques when I used it to create some chlorine and then react it with some peroxides, generating the singlet oxygen and its fantastic red chemiluminescence. This time the lights are staying on, and we're actually going to be generating some propene gas and then hydrogenating it using one of the catalyst tubes that I was just showing you. This is going to demonstrate a number of things. We'll be able to burn the product gases and see the difference between the alkene and the alkane. And the coolest thing about this is just how fantastically this demonstrates Avogadro in action as the volume changes of our gas mixture exactly in the way that we would predict. Having followed the tips in the last video to set up the gas collection apparatus, you should load your micro test tube with propan-2-ol rather than paraffin. The paraffin will work if you want to just show the difference in the flames, but if you want to demonstrate Avogadro's law, it's not so good. Some of the gases that you collect aren't alkenes, and so the volume change is a bit poor. For essentially pure propene, the dehydration of propan-2-ol will get you there. As I mentioned last time, the ethanol burner ought to be positioned a little bit further from the substrate than you had it in the cracking setup. Don't forget to discard the first portion of expanded air before the propene starts collecting in earnest. So let's talk about the catalyst tube. In here I have 0.5 grams of pellets. The pellets are 3.2 mil in diameter, and that means they fit perfectly inside the regular 1/8 inch borosilicate tubing that you're going to have lying around in the department already. The initial outlay, I'll admit, can be a little bit on the expensive side. So you're looking at the moment in the UK, if you buy a 50-gram bottle of this stuff, it's going to cost about £82. But you only need 0.5 grams of pellets to actually make a tube, and actually so therefore you're looking at maybe 82 pence per tube, and each tube is virtually endlessly reusable. So if you have the potential to get together with a group of schools nearby for a group purchase, you can actually make a ton of these for actually a relatively small investment. Having put in 0.5 gram of pellets into the tube, you can flame polish the ends. This has the benefit of locking in the pellets so that they don't get lost, and it also makes it easier to slip on a silicone tube to connect to your syringe. Now in Bruce's book, he mentions that the pellets that he was using actually arrived kind of tan colored on arrival. Now these ones, when they came to me, they were black, and he recommends that when you first use the pellets that you need to prepare them by heating the tube in a Bunsen flame until the pellets go black. I found that I didn't need to do that, so depending on where you're getting these in the world, if your pellets aren't black on arrival, you might want to investigate that as a possibility if you find that there's some aspect of this demonstration that doesn't work for you. However, I found mine just worked straight out of the bottle. I'm using the same Luer lock stopcocks as before, but as I mentioned in the last video, in principle everything here that can be done with them can also be accomplished with a piece of sticky tack on the end of the tube instead. I've used Bruce's technique for loading a syringe with hydrogen. You can head back and see me explaining this in more detail in the singlet oxygen demonstration at the link below, or of course if you have a hydrogen cylinder you can load from that. If not, then 0.05 grams of magnesium and 3 to 5 ml of 1 molar HCl will give you enough H2 to work with. So on the right side I have 30 ml of propene, and on the left side I have my hydrogen syringe. First I flushed through the catalyst tube with hydrogen, and I'm running the hydrogen syringe down to 30 ml at the same time. So I now have 30 ml of gas on each side for a total of 60 ml. By passing the gas over the catalyst, the reaction proceeds. You can feel the catalyst tube, it will be warm to the touch. With each pass, the total volume drops, fast at first, naturally, and then slowly converging in on 30 ml, beautifully demonstrating Avogadro's law as hydrogen and propene combine to simply give propane. For a finale, the product gas will burn with a nice clean flame in comparison to the alkene you started with. The demonstration can be repeated with ethine, by the way. Here, of course, the volume drops to a third of where it started rather than halfway. This catalyst tube is awesome. I'm so grateful for Bob for bringing this into my life. Go and check out Bruce Batson's book. You'll see the various range of reactions that you can undertake with one of these tubes. It really will open up some educational opportunities for you. So if you can, get a team together, go out, grab some of these pellets and see what they can do for you too.